This is an orthokeratology case where the patient has worn lenses for about a week but is not getting satisfactory vision and is also getting some halos. The maps show a very large pupil in each eye, which was indicated in the history. And then in the right eye, we can see that the lens is decentering nasally and slightly inferiorly. And same thing in the left eye, it's decentering slightly nasally, mostly inferiorly. So one thing that's working in our favor is this patient is a little bit younger, and they usually do adapt to halos a little bit better than adults would. And I think just over time, the halos will improve. But if we can get this lens to center a little bit, that will also help. The reduced vision, I think vision was around 20/30 or 20/40. No over refraction was included in the case, so I'm not sure if it's truly a plain over refraction and just poor vision, or if the over refraction was accidentally left out. But the treatment zones look pretty uniform. I don't see any unusual astigmatism or unusual pattern to the treatment zone, so I would expect this patient to be, if not uncorrected 20/20, at least correctable to 20/20 with an over-refraction. So if that was just accidentally left out of the case, then that needs to be added into the lens for the new design as well. So to get these lenses to center a little bit better, what I'm going to do is steepen the periphery of both lenses. Any kind of lateral decentration, steepening the periphery often helps. With inferior decentration, sometimes flattening the lens helps, but in this case, because I see a little bit of looseness down here, I'm going to try steepening that lens first so it bears down more inferiorly, and that should help to push the lens up a little bit. So I'm going to bring up the right lens. And we're already at the maximum diameter for this patient. 10/9 is about a 10/9 cornea. Really can't go any bigger. I think you have a second lens in freeform. I didn't get that in the clinical support files. This looks like is your first lens in GSIM, and I think GSIM is fine for this patient. There's not too much asymmetry, and leaving in GSIM with some lens adjustments I think would work fine. So to steepen the periphery, I'm just going to go to the blue dot here. Right now we're starting with about 2.7 microns of central clearance. And if I click down about 4 times, now we're at about 7.7. So right about 5 microns worth of change. And I like to work with about 5 micron increments. Sometimes we can do a little bit more, but if we overshoot, then sometimes we get problems where we get too much lift centrally and we start inducing central islands, and the patient has a poor result. So we've brought the periphery of the lens down close to the cornea. The next thing I'm going to do is go to 25% mode. I'm just going to go through here and make sure we haven't had any unusual changes to the curvature in the graph, and that looks good. So it doesn't really look like we need any touch-up. As far as the power of the lens, I think where you are is fine. A 1.3 and a 8.0 base curve for a cornea minus 2.25, initially 7.37, is pretty standard, I think, is what I would expect to work. If you find that you do have an over-refraction, say the patient needs another minus 50 or minus 75 to get to 20/20, and you would just incorporate that into here by clicking up until your new power is that much greater than the existing power to compensate for whatever over-refraction you measured. So that's it for the right lens. I'll bring up the left side. Again, we're at 10/9 GSIM. I think it's fine to leave it in GSIM. And we're going to go from 2.8, and our target will be no more than 7.8. So 4 clicks, usually around 5 microns. We're at 7.7, that's pretty good. Okay, I'm going to go through each meridian again and make sure nothing unusual happens to the teardrop. Sometimes when you steepen the periphery or you change the power of the lens, we get unusual kinks in the graph, and I just want to make sure we don't have any of those. and all those look good. So a fairly straightforward change to the lens. This should help lenses to center a little bit better, hopefully help with the issue of halos, and they get some better vision. Again, if you need to incorporate an over-refraction, then it's done here at the red control point. Also, now that we're bringing the periphery of this lens down closer to the cornea, you're going to get a little bit more seal off, and the patient may notice that the new lenses are just